Ever wonder what it actually takes to build and run a website? Like when you just go to UseItCoin.ca?
Yeah, it's easy to take for granted, right? Just type it in and boom, there it is.
Well, today we're digging deep into what's going on behind the scenes, the tools and processes that bring a site like that to life in the modern world.
It's more than just some HTML and a bit of JavaScript, that's for sure.
Exactly. We've actually got the details on the entire setup for usecoin.ca, the stack of technologies they used, and their whole workflow. And get this.
It's fascinating how these same ideas can be applied to, well, pretty much anything you can build online.
Yeah. Like imagine taking those same principles and applying them to something like, say, an ebook marketplace, which we'll call tomestack.com for now.
That's a cool example.
Yeah.
See, the real magic here is understanding those core principles and technologies, because then you get how modern web development really works.
That's our mission for this deep dive. We're going to extract those key insights from all the nitty-gritty details so you can understand what's happening without needing a computer science degree.
And I think you'll be surprised by how interconnected everything is. It's like a whole ecosystem working together.
I'm ready for some aha moments, so let's jump in. First up, containerization, which is a fancy way of saying...
Putting things in boxes.
Well, kind of. It's about using Docker to create these isolated environments called containers.
Okay, so instead of having your whole application just sprawled out, Docker lets you bundle up everything a specific part of your application needs to run. It's like a self-contained unit.
Yeah, like think of the UseItCoin blockchain functionality that would be in one container, right? And then the Node.js code that handles the user interface and the backend logic, that'd be in another.
And everything, each part needs to run properly. The code itself, libraries, settings, all that, it's all bundled up together. The source material specifically mentions Nicholas Carlson used UseItCoin rec test image. I guess that's the name of the Docker image for this. That's right. And the brilliance of Docker is that once you've created this image, it behaves the same way no matter where it's running a developer's computer, a testing server, or even the live website. It's like a guaranteed recipe.
That must make things so much easier for developers. No more, well, it works on my machine.
Right. No more of that. Docker solves the "it works on my machine" problem, and it helps make sure everything runs smoothly and consistently.
Okay, so now we've got these neatly packaged containers. But UseItCoin.ca wasn't just one container, right? It was a bunch of different containers that had to work together.
Absolutely. You need a way to orchestrate them, to define how they interact as a single application. That's where Docker Compose steps in. It's like the conductor of the orchestra.
And the docker-compose.aml file is basically the sheet music.
Exactly. It lays out the entire setup, specifies each container and how they should be connected. And the beauty of it is you can launch the whole application with one simple command. Docker Compose up, boom, everything's running, talking to each other, just like it should.
Pretty efficient. So now our app is all bundled up in containers, ready to go. But it needs a place to live, right? Somewhere accessible on the internet. That's where the cloud comes in specifically, DigitalOcean in this case.
Right, we need a server. DigitalOcean provides these virtual private servers, or VPSs, that they call droplets. It's like renting a computer in the cloud.
Ah, so it's not like we're buying an actual physical server and putting it in a data center somewhere.
Yeah, it's all virtualized. For usecoin.ca, they went with a specific configuration, which was Ubuntu S1 vCPU 2GB Varns Phi 3 Etero 1, running Ubuntu 22.04 in this Phi 3 region.
That sounds incredibly specific. What's the significance of all those details?
Well, it tells you how much processing power the droplet has, how much memory it's got, even where in the world it's physically located. That's important for performance and latency, things like that.
I see. And importantly, this droplet gives usecoin.ca a public IP address, which was, let me see, 24.199.71.39. It even says reserved IP is that significant.
Yeah, a reserved IP is a static, unchanging address, which is super important for reliability. If the IP address kept changing, people wouldn't be able to find the website consistently. Now, you might think that when someone types in https.usecoin.ca, their request goes directly to those Docker containers.
Yeah, I kind of assumed that. What actually happens?
There's an intermediary, another piece of software that acts like a gatekeeper. It's called a web server, or sometimes a reverse proxy.
Ah, so there's more to it. What options are there?
Well, there's Nginx, which is known for being super robust and handling a lot of traffic.
Yeah.
But there's also Caddy, which is a more modern alternative. It's simpler to set up and even handles HTTPS automatically.
Cool. Less configuration is always good. So what exactly does this web server, this reverse proxy, do?
It does a lot.
Mhm.
First off, it receives all the incoming traffic on the standard web ports, port 80 for regular HTTP, and the secure port 443 for HTTPS. It's the first point of contact.
Okay, so it's the front door.
Right. And it handles those SSL/TLS certificates, which are basically digital IDs that verify the website is legit, and also encrypt the communication between your browser and the server. Okay. That's what makes the little padlock icon appear in your browser, and it keeps all the data private.
Yeah, that's important. So it handles security, and then what happens to the request after that?
After decrypting the request, the reverse proxy then sends it to the right place within your application. In the case of UseItCoin.ca, it would forward it to the Node.js application container, probably running on something like port 3000 internally.
So it knows which container should actually handle the request. It's pretty smart. And I remember reading that the reverse proxy can also be used to serve static files like images or even basic HTML.
Oh, absolutely. While dynamic content is often handled by something like the Node.js application, Nginx, for example, is fantastic at serving static files really efficiently.
Right.
That can speed up your website a lot.
Makes sense. Okay, now we've got our containers, we've got our server, and we've got this gatekeeper managing things. But how do people actually find UseItCoin.ca in the first place?
That's where domain names and the magic of DNS come in.
Yeah, I mean, I'm not going to remember an IP address like 24.199.71.39, so having a name like UseItCoin.ca makes a huge difference. That's where domain registration comes in, right? And the source material mentions Namecheap.
Right. They use Namecheap to register the domain, but there are tons of options like GoDaddy, Google Domains, even Gandhi. You basically pay a fee to reserve that name for a certain amount of time.
So we've got the name, but how does that name actually get connected to that IP address we saw earlier?
That's DNS, the domain name system. Think of it like a giant phone book for the internet. When you type in UseItCoin.ca, your computer asks DNS, hey, what's the IP address for this name?
And then DNS says, oh, UseItCoin.ca, that's 24.199.71.39.
Bingo. You'd configure your DNS records to point to the IP address of your DigitalOcean droplet, and voila, people can find your site.
Now, all this code and configuration for UseItCoin.ca, it didn't just appear out of thin air, did it? That's where things like Git and GitHub come in, along with this whole CI/CD process, which always seems kind of mysterious.
Yeah, you need a way to manage the development and deployment of your application in a professional, organized way. That's where version control with Git comes in. It's like tracking every little change you make to your code so you can always go back to previous versions if needed.
So like an undo button, but way more powerful.
Way more powerful. And GitHub is like a central hub for all these Git repositories. It's where the code for UseItCoin.ca lives, along with all the history and all the different versions. In fact, the source material mentions Nicholas Carlson UseItCoin.ca as the repository name. You mentioned branching and pull requests earlier. How do those fit into this whole thing?
Yeah, I'm still not entirely clear on that. It sounds very developer-y.
Okay, so branching lets developers work on new features or bug fixes, kind of in their own little sandbox. It doesn't affect the main code base until they're ready.
Makes sense. You don't want half-finished features breaking the live site.
Exactly. And then when they're done, they create a pull request, which is basically a request to merge their changes back into the main code base. It's a way to review the code, discuss any potential issues, and make sure everything's good before it goes live. Now, to make this whole process even smoother and more reliable, UseItCoin.ca used GitHub Actions for what's called CI/CD. That stands for Continuous Integration and Continuous Deployment.
CI/CD always sounds a bit intimidating. Break it down for me.
No problem. So continuous integration, or CI, is all about automatically checking the quality of your code every time someone makes a change. Like when a developer pushes new code GitHub or creates a pull request, GitHub Actions can automatically run a bunch of checks.
Okay, so it's like having a robot QA team that constantly tests everything.
That's a good way to put it. They can install dependencies, build the application, run automated tests, even check for security vulnerabilities. The goal is to catch any problems as early as possible before the code gets merged into the main branch. The source material actually points to a file called sia.iml, which is where these checks are defined.
That's super valuable. Finding bugs early saves everyone a lot of headache later. So that's CI. What about CD, the continuous deployment part?
CD takes it a step further. Once the code has passed all the CI checks and is deemed good to go, usually after it's merged into the main branch, CD automatically deploys it to the live server, which in our case is that DigitalOcean droplet we talked about.
Wow, so no more manually copying files and running commands to update the website?
Nope, it's all automated. The source material specifically calls out deploy.iml as the workflow file. This one would handle things like connecting to the server, getting the latest code from GitHub, rebuilding the Docker images if necessary, and then restarting the application with the new code.
So a developer writes some code, pushes it to GitHub, it gets checked for quality, and then boom, it's live on UseItCoin.ca all automatically.
That's the idea. It's efficient, reliable, and it minimizes the risk of human error.
Impressive. All this automation and these streamlined workflows, they're not just about convenience, are they? They're based on some fundamental software engineering principles.
You got it. The source material highlights a few key principles, like consistency, automation, and even something called infrastructure as code light.
Let's break those down. Consistency seems pretty self-explanatory. You want things to work the same way everywhere.
Right. And Docker is key to achieving that. Because everything's packaged up in containers, the application runs in a standardized environment across development, testing, and production. No more inconsistencies between different environments causing headaches.
And automation, well, we've been talking about that a lot already. It's all about efficiency and reducing those manual errors.
Exactly. CI/CD is a prime example of automation in action. It saves time, reduces errors, and lets you deploy new features and bug fixes much faster. Now, infrastructure as code light, that's a mouthful. What's that all about?
Yeah, what's the light part mean? It's like diet IAC.
Kinda. Think of it like this. You're treating your server setup like software code. Instead of manually configuring everything, you define your infrastructure in code files, like those Docker files and that docker-compose.eml file we talked about.
Ah, so instead of clicking around in some control panel or typing commands, everything's defined in code that can be tracked and managed with Git, just like the application code itself.
That's the idea. It makes it easier to set up new servers, recover from disasters, and scale your infrastructure. It's a simplified version of full-blown infrastructure as code, but it embodies the same core principles.
Makes sense. And the source material mentions two other principles, modularity and security. How do those fit into the picture?
Well, modularity is all about breaking down your application into separate components. Like with UseItCoin.ca, you've got the blockchain node, the back-end API, maybe even the front end in separate containers. This separation makes it much easier to develop, deploy, and scale things independently.
So you can update one part of the application without affecting the rest.
Exactly.
Yeah.
And security, well, that's a huge topic. But the source material mentions a few key aspects, using HTTPS for encrypted communication, setting up firewalls on the server to block unauthorized access, using GitHub secrets to store sensitive information, things like that.
So it's a multi-layered approach to keep everything secure. So we've covered a lot of ground here. From containerization with Docker to automated deployments with GitHub Actions, all running on a DigitalOcean droplet, accessible via a domain name, and built on these solid engineering principles. Pretty impressive.
It is. And what's really cool is that these same principles and tools that we've been talking about in the context of UseItCoin.ca, they can be applied to all sorts of web applications. Like, remember that ebook marketplace idea we were talking about, tomestack.com?
Yeah, that's a great example. Let's walk through that a bit. So tomestack.com would have different features than UseItCoin.ca, right? User accounts, book listings, payment processing, things like that.
Absolutely. But the underlying engineering foundation could be very similar. You'd probably still use Docker and Docker Compose to containerize the application.
So we'd have separate containers for, say, the Tomestack backend, the front end, the database, and that reverse proxy. It would be structured in a similar way.
That's right. The back end could be built with something like Node.js and Express. The front end could be React or Vue.js. You might choose MongoDB or PostgreSQL for your database. And yeah, you'd still have that reverse proxy, probably Caddy or Nginx, handling traffic and HTTPS. The docker-compose.iml file would orchestrate the whole thing, just like with UseItCoin.ca.
And what about hosting? Could we still use a DigitalOcean droplet for Tomestack?
DigitalOcean would be a great choice. They're known for their developer-friendly platform, affordable pricing, and robust infrastructure. You just need to choose a droplet with the appropriate resources for your application's needs.
So we'd spin up a droplet, install Docker and Docker Compose, and then we'd be good to go. And of course, we'd register the tomestack.com domain name and point its DNS records to the droplet's IP address. All that's pretty much the same as with usecoin.ca. What about the development process itself? Would we still use Git, GitHub, and those CI/CD workflows we talked about?
100%. Git and GitHub would be essential for version control and collaboration. And those CI/CD pipelines you built with GitHub Actions for UseItCoin.ca, they could be adapted for Tomestack with just a few tweaks.
So we'd still have those automated checks running on every code change, catching errors early, and then automatically deploying the updates to our live server.
You got it. You just need to adjust the specifics of those workflows to match ToneStack's requirements. For example, your CI checks would need to build and test both the front-end and back-end code, and you might have different deployment steps, maybe using a separate docker-compose.prod.iml file for production-specific configurations. But the overall process would be remarkably similar.
That's pretty mind-blowing. The same core engineering practices can be applied to build and run completely different applications. It's like this underlying framework that powers so much of the modern web.
It really is. Once you understand these fundamental principles and technologies, it demystifies a lot of what goes on behind the scenes. From a cryptocurrency tool to an ebook marketplace, the core building blocks can be surprisingly alike.
So to our listeners out there, now that you've had this glimpse behind the curtain, what other seemingly complex digital services might be built on similar principles? Take a look around at the websites and apps you use every day and see if you can start to recognize the patterns. Thanks for taking this deep dive with us.